Good evening, everyone. In the last videos, we covered very clearly up to almost 70 to 80% of syllabus we have seen. Now we came to the majority main topics, sir. These are very, very important like anything. So in that linked list is there. Of course, stack queue hashing is very easy. Linked list concept. So trees and graphs concepts are very, very important. So more concentration must be required here. Now in today's session, we are going to start linked list concept. So today and tomorrow, the class timings are same, like 7:30 to 9 o'clock I'm going to spend. So what is mean by linked list? Sir, we can say it is nothing but there are some problems with the list data structure. Of course, here list is not having that much a problem. But when compared with other programming languages, we have one concept is there called arrays. So we have so many drawbacks are there. To overcome those drawbacks, we are going for linked list. Sir, what is mean by linked list? It is nothing but something like a collection of nodes. So there are two types of nodes are there. There are two types of nodes are existed. So the first one is called as single node. So second one is called as, okay, double node, like this we have. In the single node, we have two fields will be there. One is nothing but a data field, another one is nothing but next field. In the case of double node, we have three fields. One is a previous field, another one is a data field, next one is next field. Like that we have. If you want, I will show you in the form of diagram. For example, sir, I can say this is nothing but one node. In this node, we have two fields will be there in this style. Sir, can I take another node? Yes, this is nothing but another node what we have. So this node is also having two fields. Like this. Sir, connection between these two nodes will be always possible. Connection between these two nodes is always existed. Like this, we can able to say. Sir, in these, we can take some data, like assume this is nothing but the data called 10, and this is nothing but the data called 20. This is nothing but the data called 30. Last field is not pointing to anything. It is called as something like none. Here, there will be a special pointer will be associated with always first node. That pointer is called as a head pointer. This is a linked list, sir. Sir, if you take array, the memory is always continuous. Like if you take memory location, so first node, next field will be always next node. So it is a collection of objects or collection of data with continuation memory location. Even in the list also continuation memory location will be there. But in the linked list, continuation memory locations won't be there. Sir, one data may be present here. Another data is available here. We can establish a link from here to here. So this is called as linked list. So now how to establish that links? How to get the data that we are going to discuss. So here, this one is called as node. This one is called as what? Node. The technical name for this is nothing but node. Sir, if you see this node is having two fields. The first field is called as a data field and the second field is called as a next field, which is pointing to the next node. Like this we have. Sir, if you take this is the first node, what is the next node to 10, 20? What is the next node to 20, 30? What is the next node to 30? There is no node, it will become empty. Okay. Sir, in this example, we have a pointer only to the head. Rest of the things are already having the links, right? So happily we can able to access those things. So if you remove head pointer, then this list is not properly maintained. Automatically, garbage collector is going to destroy these objects. Sir, single node is okay. what about a double node or what about a double list? Sir, very simple. My double list will be in the form of like this. Let us take here also 3 nodes. So for every node, how many fields will be there? 3 fields will be there. 3 fields will be there. And coming to the pointers, sir, very, 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 very important. What are the pointers here we are taking is, sir, do you know this first node next field is pointing to this one, and this node previous field is pointing to this one. So connections will be there in both the directions. Okay, connections will be there in both the directions. Like this we are going to take. Sir, what about the last field? Last field is associated with none. First field is associated with none. Let us consider the data is 11, 22 and 33. Here also, so first pointer will be there, which is always pointing by head. In this diagram also, do you know this one is called as node? This one is called as what? Node. In this there are 3 fields are there. Okay, in this there are how many fields are there, sir? 3 fields are there. This middle field is called as data field, and this field is called as next field, and this field is called as previous field. So data field contain the data, next field contain a pointer which is pointing to the next node of same type, and the previous pointer is pointing to the node which is of same type. Like this we have. So do you know these type of things are called as linked list? So the following are the different types of linked lists. So we are going to implement programs on this. The first one is called as a single linked list. The second one is called as double linked list. Sir, third one is there, circular single linked list. Okay. Then we have circular, okay, circular double linked list. Like this, we have 4 types of linked lists are existed. Sir, I know about this single linked list, double linked list. What is this circular linked list? Very simple, sir. Here, last node is attached to the first. This is called as, before that it is single linked list. Now it is called as a circular single linked list. Because the last node next field is not none, it is connected to the beginning. In this case, the last node next field is connected to the first one, and the first field next node is connected to the last. So this one is called as what, sir? Linked list. I think you people got some terminologies related to the linked list. Of course, if you are clear with this, we can go for implementing the program. Only programs are there, sir. Can you please confirm everyone, guys? Is the theoretical concept related to the representation of nodes? Is it clear for you people?
Yes, sir. Clear.
Any doubts are you feeling? Try to clarify if you have any doubts here itself. Please respond.
No, sir, clear.
Now, sir, now what we are going to do here is, next one, very, 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 very important. We have to implement a single linked list in today's session. Sir, the following are the most commonly performed operations on linked list. Sir, we have some 20 operations that we are going to explain. The first operation, creation of linked list. Okay. Next, and after that, insertion of a node into linked list at first. Okay. Otherwise, I will write insertion at first location. Sir, next operation, I want to do insertion at last location. Sir, I want to do insertion at a given location. Sir, I will give the position. In that position, you have to add. Sir, similarly, sorted insertion in ascending order. Sir, I will add the elements into the linked list by using sorted insertion, so that whenever you are adding, it has to find the appropriate position. In that position, it has to be accommodated. Then sorted insertion in descending order. Next, we are going to see the displaying of the linked list. Some people may use the word called traversing. Sir, next term, so size of linked list. How you can able to find out the size of a linked list? And I want to find middle elements. Okay, so middle element in linked list. In linked list, I want to return the middle element content. Sir, next I want to perform delete at first location. Sir, next I want to delete at last location. I want to delete at a given location. Sir, I don't know about location, but I have element. So delete an element. Okay. So now I want to delete elements. If duplicates are there, I want to delete. So I want to implement a search operation. There are two ways are there for doing this search operation. 2 or 3 ways will be there. So search operation, what you can call the case 1 and case 2 I am going to discuss, and even search operation. So I am taking case 3, and for the same search operation I will discuss the case 4. Multiple cases are there. Anyway, we will discuss how it is going to work. Sir, after this I want to remove duplicates in sorted linked list. If you have a sorted linked list is there, I want to remove the duplicates. Next, I want to copy the list. Okay. So next operation, I want to reverse the list. Reverse the list. So I have a linked list is there. I want to reverse that. Next, I want to check comparison or compare two list objects, two linked lists. I want to compare two linked lists for equality purpose. And I want to return nth node. So from beginning, nth node from the beginning and nth node from the ending. Next, in the display, okay, in the display, of course, we have to write there itself display using loops, and I want to display the elements by using recursion. Display or traversing using loops, sorry, using recursion. There are two ways are there. So these are nothing but what are the various common operations that we are going to perform on linked list. Sir, if I cover these applications, it is more than sufficient for you to understand. Okay, it is more than sufficient for you to understand. So palindrome list, palindrome or not, our linked list is palindrome or not. Like these are the common 25 methods, 25 operations that I am going to perform on linked list. Probably we will see these operations on single linked list, and whereas coming to the double linked list, I will remove maximum. I will try to concentrate on insertion and deletion more on the remaining things, because rest of the operations how we performed in the single linked list, in the same way you have to do. Okay, sir, please confirm, shall we start the cinema? Please confirm everyone.
Yes.
Yes, sir.
Right. Sir, to do this, we have to write the single program, right? We have to write a single program to demonstrate all these things. So I don't want to make confuse for you people. That's why to practice this, I am opening Anaconda Navigator. From that, we will use Jupyter. Jupyter notebook we will see, we are going to get a browser in that you can type the commands and you can execute. So that will be very convenient for us. So to understand, I mean, the flow of execution, when you are adding, what will happen, when you are removing, what will happen. If you want to understand those terminologies, then doing the program in the Jupyter lab, that is Jupyter notebook, is very convenient. Okay. Anyway, it takes some time to start. Before that, can you please confirm everyone, is the operations what we are going to perform on this are clear for you people? Yes, please confirm everyone.
Yes, sir.
Yes, sir.
Right. You can see this is nothing but the Jupyter notebook what we have. I'm going to create a new notebook. We will try to do the programs here. I'm going to give this name as linked lists. Okay. So 8 p.m. 8 p.m. like this I'm going to give. Sir, for this total program, you will receive that PDF. Okay. So Jupyter notebook. Okay. Jupyter notebook PDF will be there. PDF document I will share. So maybe that notebook file also I will share. So here you won't get any programs, sir. Whatever I'm going to do, that will be there in this particular channel on. Okay. Please try to refer this. So I think everyone know how we are going to working with this. If you don't know, just see, we are going to write the command here, program, and we will click on this run. It is going to display the output. Okay. And this entire file is a single scope. Like if you take a is equal to 10. So after execution, in the next line, if you print a, we will get output as a 10. Whatever content is there here, you can able to get. That is the reason why we are using this. Sir, in this, I told very clearly, for creating, for performing all these operations, creation of linked list is very, very important. So I'm talking about that first operation. I want to create creation of a linked list. This is the very, 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 very important operation that we have to do here. Sir, how to create? So in the beginning itself, I told, okay, in the beginning itself, I told, sir, is there any full screen mode here? Can you please confirm anyone, those who are professionals in this? Do we have any full screen?
No, sir.
At least browser full screen we can use. Sir, can you please confirm, is it visible for everyone?
Yes, sir.
Yes, sir.
Right. Sir, we know very well how we are going to represent the nodes. Like I told, every node is represented in this style. Okay, every node is represented in this style. So I'm taking this one name as a node. And this field is what? Data field. And this field is what? Next field. Like this I'm going to take. Sir, we have to use object-oriented concept called class node. In these two fields, we have to define. One is a data field, another one is nothing but next field. Sir, when we create a new node, the data field, whatever data that you are giving, that will become data field. And the next default value is none. Sir, in linked list, generally the people are going to use the word called null, sir. Okay, in Java, in C language, in C++, so in JavaScript, the popular term is nothing but null. But in Python, we don't have this. That's why, so we have to depend on one more variable called none. Sometimes I may use the word called null. Please ignore and concentrate. The content is none. Okay, none and null, both are same in this session, sir. Please ignore if I am using null multiple times, because that is the common word. That is the reason. Now I want to create a single linked list class. So I'm taking a class node. I'm taking a class node. In this, whenever you are creating an object, what will happen? The constructor will get a chance, right? That's why underscore underscore init underscore underscore, I'm creating a self. And self dot data is equal to the data what you are giving at the time of creation. So self dot next will become none. This is nothing but the representation of single linked list, sir. This is the code what we have. Sir, now if I want to create any node, just we will create by calling like this node of 10. If you call like this, what will happen? Sir, immediately constructor is going to execute because we are creating an object with some content. So it will create a physical node like this. Its data is a 10. Next field is nothing but a none. Sir, what is the name of this particular node? We have not given anything. It can be either A, or it can be either B, or it can be either C. Any name you can use. Sir, we are going to connect the links in this style, right? We are going to create multiple nodes and we are going to create the connection between these. So how many nodes a linked list can contain? Infinite nodes. Sir, if you have infinite nodes, so like assume I have 1000 nodes are there. Is it recommended to give names for all these nodes? No. You can give pointer which is pointing to only first node. That pointer is called as what, sir? Head. In the entire linked list, we will have only one pointer. What is that a pointer? Head. Okay, like that we are going to get. Now see, I will create the first node. Here we have taken the first node, right? What is the first node here? 10. I am trying to create that node. Sir, can I take head is equal to node of 10? Yes, I created the first node. Can we print that data? How to print? Sir, head is the node. If you call data, it is going to print 10 or not? Yes. If you want to just run the code and check. Sir, now I want to create a second node. How to create? Head dot next is pointing to a new node with content 20. Sir, if you print head dot data, head is pointing at 10. If you print head dot next, it's a data. If you are trying to ask, we will get 20. If it is correct, let us cross check. Yes. Sir, I want to create one more node. Head dot next, its next field is nothing but node of 30. Sir, if you print head dot data, initially my head is pointing at 10. So if you print head dot next, that means head node is 10. Its next node is nothing but 12. 20 in this example. And if you are trying to get data for that, what will happen? It will return 20. Sir, I want to take head node. Its next field that is 20. Its next field that is 30. It's a data I am trying to print where we will get 30. If I am not wrong, you can see here. Right? Sir, I want to take the same thing. So last one, I am trying to take head dot next, dot next, dot next, dot next, dot data. So I am trying to use fourth node, but is there any chance of getting fourth node? No. Then what will happen? We are going to get error. None type object has no attribute called data. So we don't have any last node. Then how you are accessing data? If you are trying to call next, you can see here the last node is pointing to which one, sir? None. Okay, like we created some nodes here and we have assigned some values. So what are the values that we have assigned? 20 and then 30. So now this node name is nothing but what? Head. This node name is nothing but what? Head dot next. It is not name, just next pointer. And if you want to access this one, head dot next dot next. Sir, if I want to create like this 10 nodes, sir, we have to take head dot next, not next, not next. So dot next like that. No, we can use just for understanding purpose. I am telling like this. We can use one function like insert at first. So it will add a new node at the beginning. Insert at last. It will add a new node at ending. In that function, we are going to write the links to establish the connection. I can insert here. So I will break this link and I will make like this. So all these operations we can perform with the help of functions. Sir, now I think the creation of linked list class it is very clear for you people. Can you please confirm any doubts, friends, up to this, whatever we covered?
No, sir.
So if you understood whatever I explained till now, rest of the things are dead easy.
Yes, sir. Yes, sir.
Is it clear? Please respond. Right. So now we are going to implement the methods one by one. Sir, this one is okay. This one is okay. But this one is not good by taking head dot data, head dot next dot data. Like that, I don't know how many times it is going to come. That's why I am start implementing these methods on single linked list. Okay. So let us see what are the operations that we can perform. First operation, I think creation of linked list is okay. Now I will work on display function I will implement. Let us see how we can write the code. I am defining one function like a print list. So which is going to take a pointer called head. Okay, print list, it is going to take a pointer called head. We have to print the content based on this. Okay. Now, let us see how I am going to write code for this. Please listen, friends. There are two cases are there. Sir, first case, in my linked list, I don't have any elements. So your head is pointing at none. If there is no elements, head will become none. Consider second case, I have some elements are there, like some 3 elements are existed in my list. Let us consider same content. Like we have 10 is there, so 20 is there, 30 is there, last field is none. This field next one is connected to this field next one is connected to this, but name of this first field is nothing but what head. This one alone I have. These are the two cases. Now print list, I passed head. Based on this we have to check. Sir, I will do temp is equal to head. Whatever the head is pointing, now I am creating one temporary node here and temporary node here. Sir, there are two cases are there. What is the first case? Boss, if your temp is equal to none, then what is the meaning? The linked list is empty, right? Okay, the linked list is empty. Just I am going to print the message saying list is empty. Can you please stop? Can you please return? Stop. Suppose my list is not empty. Then what we have to do? Your temp is pointing here. We have to print this data. Sir, after printing the data, I will move this temp to this one and I will print the data. And I will move this temp to this one and I will print the data. I will move temp to the next. Next one will become what? None. It will stop printing the data. This part I am going to write with the help of code. While loop I am taking because I don't know how many nodes are there until your temp is not equal to none. Sir, what we are doing? Just we are printing the message like temp dot data, and I am going to give end is equal to space. That's all. After this, your temp will become temp dot next. This is the code to perform display operation. Let us first dry run this code. Sir, initially my temp is pointing at a 10. Now tell me, is a temp is equal to none? No, it is not equal to none. Then what will happen? It is printing the temp dot data, which is nothing but 10. Then temp is equal to temp dot next. Identify the next node to the temp. Which one? 20. Now my 20 will become temp. Since it is a local variable, once if you reassign the value, automatically this value will be erased. Now, since it is a loop, second time it is checking. Is temp is not equal to none? Yes, it is not equal to none. Can you please print temp dot data and transfer the control like temp is equal to temp dot next? Right. Again, while loop, it is not equal to none. It will print the temp dot data and temp is equal to temp dot next. Now my temp is pointing at which location? None. Now, is a temp is not equal to none? No, temp is equal to none. Can you please stop printing the data? Sir, can we say these are the three elements which are present in the linked list or not? Yes. Now let us run this code. But if I want to run this code, I have to write the code. Already head is there, right? Just I am trying to call. So print list by passing head, because already we have some nodes are there here. You can see already we assigned head pointer is there. Sir, now I want to run this code. Just run. Now you can see print list is not defined. So print list is not defined. What is the problem here? Sir, is the spelling mistake? No. Actually, we have not executed this code. Once if we execute, then only scope will be created. Now I am running. Sir, are you seeing here? We are getting 10, 20, 30. Can you do modification like I need in the form of linked list? I will give arrow mark, run this and run this. You can see 10, next node is 20, next node is 30. Sir, can we print none here at the last? Yes, why can't? After completion of this, just I am trying to print the message called none. Run this and run this. Now you can see a perfect linked list got executed. Sir, everyone, can you please confirm? Is the printing list, is it clear for you people? Everyone?
Yes, sir. Clear.
Only few people are responding. I request everyone to please confirm. Any doubts up to this?
No, sir. All clear.
Clear, sir.
I am wondering that you people are not asking the doubts. Huh? Really, is it easy or you people are simply skipping?
It is easy. You are like just printing the elements of the list by iterating through each
Mhm.
node.
Right.
And
Very good. If you understand these concepts, then I am the luckiest person, sir.
Hello, sir. Sir, I'm having the means just a terminology. I'm just confusing regarding a head, sir. So is
Ah.
it with the reference to the head and tail, right, sir? Means
Yeah,
tail
it is.
concept is not there, but head
Yeah,
tail concept is
is
like
yes, yes. Head is always pointing at the first node. Tail is
first.
always pointing at the last node. But here I have not used any tail concept.
Yes, sir.
Okay.
So
So
first element, yes, first
yes, first
element will be always be the
always a
head,
head. Yes, yes.
and
So how to identify the second element? From the first element only you have to identify second element. So head
yes.
is the main pointer. By using that only, you have to point the remaining nodes. Got it?
And what if, sir, the arrow mark which is going towards the right? But what if the arrow moves left side? Then what will be the head, sir?
No, 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 no. Here we have only the pointer to the next node, not to the previous. We don't have any arrow mark to the left. Okay.
Okay.
So that we will discuss in the tomorrow's session. That is called as a double linked list.
Okay. I mean, sir, it always moves from left to right.
Yes, if
Right.
it is moving from left to right, then it
And
is
the
a single linked list.
and
If it is
leftmost.
moving, yeah.
Yes.
If it is moving from left to right, as well as from right to left, means it is double linked list.
Yes, sir. But in single linked list, it always follows from left to right, and leftmost the list which is there, that is known as the head, right?
Yes, yes, yes.
And one more thing, sir, that data and next, which you told regarding that. So the numerical part where you wrote 10, 20, 30, that is known as the data part.
Yes,
And
yes.
the next one, that is which is connected to the next
Next
list,
node. Next node.
node, sorry, next node. So that will be the next.
Yes.
Yeah.
In the beginning, I told, right, we created one class called a node.
Yes.
So data field is representing integer here. Next field is pointing to the next node. It is of type node.
Yes, sir.
And the data field, you can choose anything. Just for example sake, I am taking the numerical values. It can be anything, like you can take student objects, or you can take string values, anything we can take.
Yes.
Okay.
Sir, you have used here like what we call like parameterized constructor. So we can also use the default constructor while like
No,
defining the
here parameterized constructor is mandatory. So why? Because when we are creating a new object, I mean when you are creating a new node, it is your duty to pass the input, right? I mean, what is the data of that node compulsory you have to provide.
like sir, if user is not providing any data, so by default we can take the value
No,
as zero.
no, we can't take. See, sometimes if you are taking like that, then what will happen? So every time it will create with the data only. It is compulsory you have to provide the data. It is your duty. So if you want to avoid, maybe one time it is possible. But if I am creating the node class object without writing the data for 3 to 4 times, then duplicate values will be there. We can't take any node with content 0, right? It won't be good. That's why. So it is a constructor overriding we can do. I mean, overloading we can do. That is a secondary case. But make sure that when you are creating the node, we are passing only data field. Next field will be by default none. That links we will assign in the program. Clear?
Okay, sir, clear.
Right. Right, guys. So now what I'm going to do is very, very difficult task I'm going to do now. Sir, print list function only I'm taking. But my requirement is I want to print the data in the form of recursion. Sir, even I have not implemented this function. First time I'm writing code for this. Let us see. Print list in recursion. Print list recursion. So where it is going to take a head or anything we can take. Okay, let it be head. Okay, so I think we can't take head. If you take a head, then it won't be good. So I will do one thing. I will take some temporary node. I will take some temporary node. Okay. So what we are going to do here is we have to print the content in the form of recursion. In the form of recursion. Sir, first I will check the node what you have given is equal to none. If it is equal to none, then what we have to print? In our example, we have seen we are going to print none. We are going to print none. So, and then we can return the process. Otherwise, what we are going to do? We are going to do two steps. We will print the temp dot data and we are taking end is equal to some arrow mark like this. After that, I am calling again print list recursion. I am calling print recursion by taking temp dot next. Sir, let us run this code, how it is going to work. At least let me explain. So assume here, what will happen? This is my list initially. This is my list initially. Sir, now I'm going to create one temporary variable which is pointing to the head. This value I will pass. This temporary node I am going to pass. So 10 will be passed. Is the 10 is equal to none? No. Then print temp dot data, that is 10. Give arrow mark. We are calling the same function by passing temp dot next. That means we are giving this one as a new call. So the function is going to call from this. Is your temp is equal to none? No. Then what we are going to do? Print the temp dot data. Sir, it will be printed 20 and arrow mark. Now we are calling the same thing for temp tends to next, which will be printed 30. Now your temp is pointing to none. Then what will happen? When temp is equal to none, we will print none and then we are going to return. The program is going to come out. Sir, this is nothing but the recursive way how we can able to print the recursion. So to execute this code, you have to take another pointer temp. Assume this pointer is lead by head. Whatever head is there, I am taking it as a temp. We can call this by using head also. But if you call this by using head, what will happen? Head is keep on changing. Then our main agenda is going to be lost. That's why you should not take a head, sir. You should not change the position of head. So for that, just I am assigning temp is equal to k. Can I call print list recursion by passing this temp? happily we can call. Let us cross check whether it is working or not. Perfectly working. We got the data like 10, 20, 30. Sir, you may feel that SAR is showing the previous program output. Let us create one more head. I am taking head is equal to none. Means I am making it as a dummy. Now I am taking head is equal to, so node of, I am creating a node with 311. And head dot next is equal to, I am creating a new node with 322. So head dot next is equal to, I am creating a new node with content 333. So head dot next will become a new node with content 344. Now I have head pointers are there. So now what I am going to do, I will run this code now. Can you please cross check? Is it printing the data? Yes. This is the way how we can able to do. Sir, if any person is asking, can you please print the linked list in the reverse style? Sir, just I am going to remove this line here and I will paste. Now, if you run the code, this code is going to print the data in the reverse. Sir, you can see we are getting 444, 333, 322, 311. So why we are getting none separately? You know the reason. Sir, the simple concept for this is, so already we learned this concept by using stack. Recursion is going to push the data in the stack. At the time of pushing, if you print, we will get a 10, 20, 30. After this, if you make a call, then what will happen? It is going to print in the reverse direction. Somewhere in our recursion, so tail recursion, non-tail recursion I covered. That is the example. So with this, you got a very clear clarity how we can able to print the content present in the linked list. Sir, can you please confirm, is the recursive way, iterative way, both are clear for you people, guys? Everyone please respond. Yes, please confirm everyone. Is it clear up to this, whatever we covered? Right. So with this, we completed displaying by using loop and by using recursion. Now our main operation, I want to insert a node at the first location. Sir, please concentrate well. This is the very, very important. So I have a
Sir,
node is there.
excuse me,
Yes.
sir. Sir, can you
Yes.
please comment which question you are doing, means which code you are doing, because you are not referring and you are deleting that from that side. So we will
Okay,
get
okay.
confused at that
I am
moment.
going to take the screenshots here meanwhile, but anyway, for every operation, I will try to create. Okay. So
Yes, at
here,
least comment that which
yeah,
one
yeah,
it's
yeah, yeah.
for. Yes.
So here, this one is nothing but what I can say, display operation. Okay. So if you see, this is the display operation what we have, and this one is nothing but a display operation by using recursion. So displaying elements by using recursion. And now we are going to write the main code. Please concentrate well. So what is the here is insertion of a node at a first location. Sir, to run this code, I am going to define a function. The name of the function is nothing but insert at a first. So which is going to take two pointers. One is a head, another one is a data. So you have to insert this data into your first position. There are two cases are there. Sir, please listen carefully. The first case is my head is pointing to empty. We don't have any node. It is pointing to none. This is the first case. Second case, I have a head is there. So which is pointing to a node with content something like 10, like this I have. Okay, or with content something like 40, I have like this. So I will write both codes. Okay, later we will go for next one. We will complete that. Assume I am taking head 1 is equal to none. We don't have any node. Okay, so then what will happen? So if I print this list by passing head 1, what output we are going to get? You know, list is empty. I am taking head 2. Head 2 is equal to initially some node is there. Let it be 40. Let it be 40. Now, if you print list of head 2, so what will happen? It is going to print only 40. In these both cases, we are trying to add the element. Sir, where we are going to add? It will be added at first. Sir, in the first case, what will happen? Here you can see there is no node. In such cases, what we have to do? Whatever node that you are creating, so that will become your head node. That will become your head node. By default, this reference will be gone. Sir, when this happens, if the head value is nothing but none, that is, if your head is equal to, okay, if your head is equal to, sir, none, if your head is equal to none, then what I can able to do? Simply, I'm going to create a node. So that is nothing but temp is equal to, better I can do like this. Directly I can write the code. So temp is equal to, I am creating a node with the given data. I'm creating a node with the given data. So temp dot next is equal to head. Okay, temp dot next is equal to head, and simply I am going to return temp. In the beginning, your head is equal to none, right? Then what will happen? We are creating a new temp a new temp node. So this will become your temp node. This will become your temp node, that is newly created node. And the temp dot next is equal to head. I think that is not the correct. 1 second. So better to write, if your head is equal to none, then what we are going to do? So your head will become, okay, a new node with otherwise your temp will become head. Your temp will become head. Okay. Else, if it is not the case, then so now temp is equal to node of some data. Yes, now this code will work. See here, we are creating a new node. If head is equal to none, that means the first case. So what we are doing? Temp is equal to head. This is the temp, right? That will become your head now, and we are going to return that temp. Okay, that will be assigned to the head. Okay, sir, already some list is there. Then what will happen? It is going to create a new node with the content something like a 10. What is the name of this node? Just now we have seen it is a temp. Then what will happen? Is your head is equal to none? No, because head is pointing to somewhere. Then temp dot next will become head. Sir, this is nothing but a temp, right? Its next field I am going to delete, and I am making this next field pointing to this head. I am returning this temp. That temp will be assigned to some variable called head. Okay, that temp will be assigned to a variable called head. So immediately this temp will be gone and this head will be gone, and whatever content we have written, that is always pointing to the head node. So let us cross check whether it is added or not. Up to this, I think no doubts. So head is equal to, initially we have empty is there. So now I am trying to add, list is empty. So now you can see head 1 is equal to, can you please insert at first? Which data I am inserting? Let us take 333. Sir, after this I am trying to print. Sir, you can see insert first is missing. 1 second. We have to pass head at the same time, head 1 at the same time 333. Now you can see, sir, is the data got added? It is telling list is empty. I think this one is not required. Temp is equal to new node, temp dot next is equal to head. Let us run this. Yeah, sir, because here previously we are returning something, we are checking whether head is equal to none or not, but that is not required because whatever this function we are returning, that I am assigning to the head. So whatever modifications that you are doing, that will be assigned to the head. In this example, we are creating a new node. Consider my list is not there. Then what will happen? Your head will become empty. We are creating a new node with the content 333. This will become a temporary node, and temp dot next is equal to head. What is the previous head? None, right? So it will become none, and we are returning this temp. Once if you returned this temp, that will be assigned with head or not? Yes. In the second case also, if you are trying to create any node, that node will become temp. You can see temp dot next will become head, and we are returning this temp. If you return this temp, this will be assigned with the head. By default, this reference will be gone. So let us cross check. So it is working for the first case. Let us try with another case. So I will create the node now. Head is equal to, I am making none. So now head is equal to insert first, insert at first. So I am creating a node called 344, and I am trying to print this particular head. See what will happen. Somewhere we have to give again head. So please make sure that 2 pointers we have to provide. Sir, 344 got added. Can you please add one more node? Head is equal to, so insert at first. So for this head, we are trying to insert 333. Where this 333 will be inserted? Insert first means before 344, this value should come. Is it coming or not? Now I am taking head is equal to, so insert at first of head comma, I want to insert 322. Sir, now see, is the 322 is coming at the beginning? Yes. Sir, now head is equal to, so insert at first, I am taking head comma 311. Sir, is that added at the beginning or not? Yes. This is the way how this insert function, insert at function is going to work. So insert at function is going to take a node and it will add always at the beginning. Please confirm everyone, is the code is very clear for you people?
Sir, first we create the new node, then we point to the next node, right?
Yes, first we are creating a new node and we are making the links and we are returning that head.
Yeah, okay, sir.
Insertion and deletion will make you confused, sir. Once if you insert this insert and delete, remaining things will become very easy. Okay.
Okay, sir.
Right. So let us go for next one, which is very, very important. Sir, please concentrate. Insert at first is okay. Now I am taking insert at last location. Okay. So consider the same diagram I am taking. Like I have some elements are there like 311. So next node is pointing to 322. So next node is there pointing to 333. Next node is there pointing to 344. This is the linked list what we have. And the last field is pointing to none. Last is pointing to none. And the name of the first field is nothing but what? Head. In the previous case, whatever node that you are creating, that will become head, right? Because insert at first. Whatever node that you are inserting first, that will become first. But here, whatever node that you are inserting at last won't become head. That's why we are not required to touch this head. Now see how I am going to write the code. Insert at last. I will define a function called insert at last, which is going to take 2 parameters, head and then data. Sir, first we are going to check, is your head is equal to none? If your head is equal to none, then we are going to create a new node with the data and I will return that. So when it will happen, if there is no new node, I mean, if there is no nodes in the list, my list is empty. In such a cases, I am going to create a new node and I will take the data and I will throw. That will be immediately assigned to head. Otherwise, sir, do you know you have to create a new node in this position? Please follow my instructions very clearly. We have to create a new node here. Sir, how it is possible? Creation of node is very simple. Okay, so creation of node is very simple, but sir, making the links will become very difficult. So if you have a name of this node, simply the next to this node will become this one. Like that we can assign. But do we have any link to pointing to 444? No. That's why what we have to do, we have only two options. One option, you can bring this head from here to here. But once if you move head from here to here, so from this you can access left, but you can't get this 311. That's why don't touch head. What is another option? Array. Try to create a temporary variable which is pointing at the first location and check whether its next field is existed or not. If next field existed, make this one as a pointing to this one. Its next field is existed, yes, make temp is pointing to this one. Its next field is existed, make this one pointing to this one. Sir, its next field is not existed. Oh, stop here. Now this will become your temp. So how we got from beginning to ending, I think you got clarity. Sir, now what we are doing, we have a name of this node, right? Now we can delete this link. I mean, already this link is not there. Just we are establishing the connection between these two. That's all right. That we have to write. How I am going to take? Boss, your temp will become head. Your temp will become head. First node will become your head node. So what I am going to do? While temp dot next is not equal to none. Can you please move temp is equal to temp dot next? Please listen carefully. Again, I am repeating the code. Observe carefully. Sir, what I am going to do? Here, I am going to make this node as a temp. Okay, so temp is equal to head. Is a temp next field is not equal to null? Yes. Then your temp will become temp dot next. This will become temp now. Now, is next field is not equal to none? Yes. Then temp will become this one now. Sir, its next field is not equal to none. Yes, this will become temp. Sir, its next field is not equal to none. No, its next field is none. So come out from the loop. Can I write after coming out from the loop, temp dot next will become, sir, a new node with your given data. Then simply return that head. Sir, what will happen? Temp dot next will become a new node with data 355. And simply we are returning this head. If you return this head, its next node, its next node, its next node, its next node. The entire chain we are going to get, right? So this is the way how it is going to work. Let us run this code. Already we have this head, right? If you see, just if I am trying to print list of head, you can see what output we are getting. Sir, we got all the elements. Now I want to add. Okay, I want to add. So how we can able to add? You can see here. So insert at the last I am taking where I want to add 777. So insert at the last where I want to add 888. If you run this code, definitely that 777 and 888 should be added at the ending. So you have to take so two pointers. One is a head and compulsory you have to assign to the head. Otherwise, so the modifications, whatever you are doing, it won't be reflected. Now you can see, sir, in addition to that 444, is the 777 and 888 got added or not? Yes. This is the way how we can able to add an element at the end of a single linked list. Can you please confirm everyone, sir? Is the concept is clear for you people up to this, whatever I covered? Yes, please confirm, friends.
Yes, sir, clear.
Yes, sir. Clear.
Right. And before moving to the next code, I want to demonstrate one more thing. I'm taking head is equal to none. I'm trying to print list of head. We don't have any elements, right? It will become empty. Head is equal to insert at last. Can I change the data? Yes, no problem. Can I change the data? Yes, because Python is a dynamically typed programming language, right? Happily it can able to take. But what is happening? Sir, every time I'm doing this mistake,
Head is
please
missing.
ignore. Now you can see triple H is nothing but the data. Now I want to call the same function by passing. So triple W. Okay, I am passing triple Z. So now I am taking triple A. Now if you run, what will happen? All this data got added. Sir, I don't want to add last this triple A. I want to add at first. If you run, what will happen? Immediately that triple A came at the beginning. I think you got clarity how it is working. Now the next function, what I am trying to explain here is, I want to insert at a particular position. So insert a node at position or location. Sir, I want to define a function like insert at position. I'm going to pass 3 parameters, head, and I will give the position where you want to insert and then data. Sir, it is not location, it is position. So temp is equal to, definitely we have to create a node. Temp is equal to node of data. So consider I have a list is there in this style. So something like 10 is there. Its next field is pointing to 20. Its next field is pointing to 30. Its next field is pointing to 40. Its next field is pointing to 50. Like this I have. Last field is pointing to none. So where my head is pointing? So you know very well, the head pointer will be always pointing at the
First
beginning
node.
of the linked list. So now we have to insert at a position. Sir, I am creating a new node where I want to insert. Consider in between these two, I want to insert. So consider the data is nothing but a 99. So just now I created, the name of this node will become temp. The name of this node will become temp. So its next field is none. Sir, just we have to break this link and you have to assign. Beyond that, nothing. Let us see what I am doing. Sir, I am going to check if your position is equal to 1. Then, so temp dot next will become head and I am going to return that temp. Sir, assume the location where I want to insert. Sorry, not location. So position. Position is equal to 1 means what? I want to insert at first. This is the new node, right? Its next field will become the position. That's all. That is a simple pointer that we are going to do. Anyway, we are returning temp that will be assigned to the head later. So automatically it will assign. Sir, okay, fine. Now what I am going to do here is, sir, I am going to take position is equal to 1, 2, 3. Okay, so 1, 2, 3. In fourth position, I want to add. So is position is equal to 1? No. Then what we have to do? This if condition is not satisfied. Now I am taking the current node will become head node. The current node will become head node. So now my current node is pointing, CUR I am taking, my current node is pointing to 10. Sir, after this, what we are doing? For each I value in the range of position minus 2, I am taking position minus 2. Otherwise, you can declare the variable or you can run. See here, how many times we have to run? This is the current. Position value is 4. 4 minus 2 means 2. 2 times you have to move because already one pointer is completed. Another 2 nodes will be there. So we have to move up to that. So that's why I am taking a for loop which will start from 0 and it will take up to position minus 2. That means position value is 4 means 4 minus 2, 2. 0, 1, 2. So these are the values what we have. Sorry, 0, 1. Now see what will happen. Sir, I am going to make my current node is equal to, better to take CUR to get clarity. So my current node will become current node dot next. And every time I will check, is my current node is equal to none? Because if my current node become none, then what is the meaning? So we can't able to insert in a proper location. Simply I'm going to return head, because assume the position which I have given is 50. Is there any 50 position here? No. In such cases, what will happen? My current node will move up to none. So then immediately it is going to return the head without insertion. Sir, this current is not equal to none. Sir, can you please cross check here? Is current is equal to none? No. Then what we are doing? Current is equal to current tends to next. This will become current. Now, is it equal to none? No. And still we have a loop, right? Because I is going to execute 0th time we executed, and the first time it is trying to execute. So this current will become this one. Now you can see up to this, the loop is going to execute and it will stop. So task completed, it came out from the loop. Now you have a pointer. Sir, what we have to do? You need to break this link, right? How we can break the link? Sir, I am going to write, listen carefully. Sir, your temp dot next will become current dot next. Sir, what is the current dot next? It is 40, right? Your temp dot next will become current dot next. That means this temporary node next field I attached as a 40. Then after that, what we have to do? Sir, your current node is there, right? Its next field will become temporary node. So means what? This node I am going to assign. First, we have to assign this node, because if you assign first this one, this link is going to break. Then you can't identify this one. That's why this node next field is assigned to this one. This pointer will be there. So that I am going to assign to this one. So automatically this link is break, and the element which you want to insert will be perfectly added here. That's all. At last, what we have to do, sir? You need to return your head. Automatically, whatever modifications that we have done, it is going to return. Let me cross check. We created a node. If position is equal to 1, temp dot next will become head. We will return the temp. If current is equal to head, for I in the range of position minus 2, your current you are moving. And if current is equal to none, without doing any modification, we will return head. Otherwise, a temp dot next will become current dot next. Current dot next will become temp. That's all. Now you can check. Sir, I will take this one. I will take this one. Already we inserted some data here. Let us run 1122 something like it is there. Sir, now my requirement is, after this, I want to take head is equal to, can you please insert at a position? Insert at a position. So which node we need to insert? 999. In which position? 0. After that, I want to print the list by passing head. Now see whether this 999 is inserted at a 0th position or not. No. Sir, we can't take the position as a 0. Start from 1, because I told it is not location. Can you please cross check? Is 999 is added at the first position? Yes. So try to give position as a 2 and run. Sir, is it added at second position? Yes. Sir, can I take 3? Yes, third position. Sir, can I take 4? Is it added at fourth position? Yes. Sir, can I take 5? Is it added at fifth position? Yes. Sir, can I take 6? Yes, but it won't reflect anything, because 1, 2, 3, 4 positions are there. Fifth position we can insert, but sixth nodes we don't have anything. Okay, that's why we are not getting, sir. I think how this particular algorithm is working, you people got clarity, sir. Can you please confirm inserting at a specific position? Is it clear for you people, everyone?
So why didn't give
same output for 0th and second position.
Sir.
When you inserted that 0th position, it gave the same output as the second position as well.
Because you can see position is equal to 1 is going to fail. Okay. So then current is equal to head. So my current will pointing to the 10. Then for I in the range of position -2, 0 -2. So there is no chance to execute this one. Okay. So now what will happen? Temp dot next will become current dot next. So this next field is attached to 20 and the 10 next field is attached to 9. Getting the point?
Okay. Yes.
Right. Sir, clear up to this? Please confirm. Please confirm everyone. Is it clear? Sir, no response from other students.
Yes, sir, clear now, but we have to practice.
Compulsory you have to practice, otherwise it will become very difficult for you in future.
Sir, why
See-
it is not working to the last position? I didn't get that part.
Which one, Sushant?
Like why it is not working for the if we are inserting in the end position, last
Ah.
position.
No, it won't work. How it is possible? General terminology, sir. So first position, second position, third, 444. We have the data like we have 444 is there. Sorry. So here example is there, right? So first position, second position, third position, fourth position. If you are giving position as a fifth, what will happen? It is adding at the fifth because it will move up to fifth, no problem. But if you are giving 6, what will happen? So
Sir,
it is
I
not
have
doing any. 1 second, sir. Let me clarify his doubt first. So when I am giving 6, what will happen? This loop is going to run up to which position? 6. But when we are moving, so we have only 4 elements are there. When fifth element is coming, its next pointer is pointing to none. Then immediately it is going to return head without doing any modifications. This one won't execute. When it will happen? When you are going out of the range. If you want, you can calculate the size and you can put a message like you are giving the position which is not existed like that. Clear, sir? Sushant.
Yes, sir. Sir, like if we implement insert at the last, then
Hmm.
like it will work, now.
Yeah, it will work.
Like
Insert
it will
at last
bypass
means
the
what? It
size.
won't. Yes, it won't check size. So it will
Okay.
take the last element and it will insert. Insert first will insert always at the beginning. Insert at
Okay.
position, you have to give in between the first node and last node.
Okay, so like it will check between the size of the linked list.
Yes. We are not checking, just we are simply finding the appropriate position and we are inserting. If it is going beyond the limits, it is giving the simple without doing any modification. That's all.
Okay, sir.
Yes. Any doubts?
Yeah, sir, I have little bit confusion. Sir, if I am given the position is 2, then 2 minus 2 is 0. Then position is 0.
Sir, suppose consider you have given position is equal to 0. Okay. That is your doubt, right?
Yeah, sir. Yeah.
1 second. See, assume the position which you have given is 2. What will happen? 2 minus 2 will become 0. Okay.
Yeah,
Remember
yes, sir.
this point. Now, temp is created. Current is equal to pointing to head. This one will become your current node, right?
Right.
So position is equal to 2 means what? You are trying to insert in this position. Am I right?
Yes, sir, right.
Then what will happen? For I in the range of range function, position minus 2. Position is 2. 2 minus 2 will become 0. It won't generate any values, right? So
Yes, sir.
this loop is going to skip. What will happen? Temp dot next is equal to current dot next. This is the temp. Its next field is current field next. Right?
Yeah,
Then
okay.
current next will become temp. Is it correct?
Yes, sir.
Got it?
Yes, sir. Yes, sir.
Right. I think everyone got a clarity about this insertion, sir. So we have seen insert at a first location, insert at a last location, insert at a given location. So I don't want to make you confused. Better to go for the small examples. I mean, small codes. Okay. I want to find size of the linked list, sir. It is a very simple code. Okay. How you can find size of the node, we will see now. Sir, size of the node in the sense what? How many elements are there in your list? You have to count. Beyond that, nothing. Sir, let us define one special method I am taking like count, which is having head. I will initialize count is equal to 0. Sir, first we will take the diagram. For example, consider, so I have 1 is there and the next field 2 is there. Okay, so next field 3 is there. So next field 4 is there. So like this I have. So your head is there. I'm giving that head as a reference and I'm taking count is equal to 0 and I will assign temp is equal to head. That means what? Temporary node is pointing to this one. If it is not equal to null, if it is not equal to null, then we have a node, right? So I'm going to write a while loop. While your temp is not equal to none, then count will become count plus 1 and make your temp to temp dot next. Sir, now what will happen? Your temp will move to the here. Sir, it is not null, right? Previously count is 0, it became 1 here and it is not null, right? So it will become 2 and you are moving temp to here. It is not equal to 0, it will increment the count and it will move to the here. It is not equal to 0, it will increment this one and the last temp will become none. This loop is going to fail. Can I return this count value? That's all. Simply I am going to return the value of count. Sir, let us check whether this code is going to work. Already we have some nodes are there, right? Let us take this one. Let us take this one and insert at first. Let us take, so head is equal to, so insert at last. I am taking head comma. I am trying to take 355. Let us run. Sir, you can see we have this. Sir, I want to count. Okay, I want to call count function by passing head, which is going to return the number of nodes. How many nodes are there, sir? 5 nodes. Let us try to insert one more node like 666. Now, how many nodes are there? 6 nodes are there. So count function is working efficiently to count the number of nodes present in the list. Can you please confirm any doubts up to this? Please confirm everyone clear up to this.
Yes, sir.
Yes, sir, clear.
Right. Sir, now I want to implement one more function like I want to return middle element in the linked list. I want to return middle element in the linked list. How you can able to return? Okay, how you can able to return? Very simple. I'm going to calculate. I'm going to define a function called so def. Let us take the function name as a middle. I'm taking head and I will count from the 1. So I will take a temp is equal to head. Okay. And CC is equal to, I'm taking count of head, which will return the actual number of nodes. If you want better to give it as N. N is nothing but how many nodes are there in your list. While your count is less than N by 2. Okay. So you are keep on moving the count and your temp will become temp dot next. Okay. At last, can I return temp dot data? Yes. Because you can see, sir, I want a middle element. So what I am doing, I will create a temp which is pointing at the beginning. And I have 2 pointers are there, like count is equal to 1 and the number of nodes. Here we have 1, 2, 3, 4 nodes are there. So I am running the loop while count is less than n by 2. 4 by 2 means 2. The condition is true. Then count is equal to count plus 1 and we are moving temp to here. Then so check is 2 is less than 2, condition is false. So this is nothing but the middle element what we have. We are going to return temp dot data. Okay, let me cross check whether it is working. So I will run this program with this. Now instead of printing count head, I want the middle element in this. Let us cross check. Sir, you can see 333 because 1, 2, 3, 4, 5, 6 elements are there. third element will become middle. Sir, now I am trying to take another node like 777, which I am adding at the ending. Now what will be your count? It is 333 only, because 1 2 3 4 5 6 7 elements are there. 7 by 2 means as usual it is going to return 3. Sir, if you add one more element, definitely change will be there. Let us cross check, sir. I am adding 888. Can you please run the program and see? We are getting 444. Like this, it is going to return the middle element present in the linked list. Everyone please confirm, is the concept is clear for you people?
Yes, sir.
Right. So I think with this we finished some algorithms, some implementations we have seen. Okay, something like right, almost all the functions we have seen. Majority of the topics we covered. Rest of the things are a bit tricky, that we will discuss in the tomorrow's session. Sir, tomorrow also we have a class as usual at what time? 7:30. 7:30 to 9 we will have a class. Probably we will try to wind up this linked list, because these search operations are easy. Okay, and the delete operations are also very easy. Only the problem with the copy reverse operation, rest of the things are easy only. So maximum we will try to finish this linked list concept by tomorrow. Okay, I request everyone to please attend tomorrow's also. Regular class will be there from 7:30 to 9 o'clock. I will upload the running notes after half an hour or 1 hour, because immediately I have a class now. Okay, we will see the remaining things in the tomorrow's. So in the
Okay.
running notes you will have only this particular content. This PDF you are going to get whatever I typed here. This PDF you will get. Try to refer that and practice. Okay, right, sir. Thank you. See you tomorrow.
Okay, sir. Thank you, sir.
Thank you, sir.